everybody. In the last video I spoke about the synthesis of alcohols, and in this video I'll speak about the chemical reactions of the alcohols. Now the chemical reactions of alcohols occur due to some reasons. The CO and the OH bonds of the alcohols are generally polar. As a result, they are easily attacked by the polar reagents, and as a result these bonds generally break. Also, the oxygen atom of the OH group of alcohols consists of two lone pairs of electrons and hence can act as electron donors. Okay, now I will come to the chemical reactions of alcohols. First is the reaction with metals. Alcohols react with active metals like potassium or sodium, resulting in the formation of metal alkoxides plus hydrogen. In case of tertiary butyl alcohol, aluminium will be used as a metal. Now I will come to the reaction of metal hydrides with alcohol. Metal hydrides like sodium hydride reacts with alcohol to give metal alkoxides plus hydrogen. Next is the reaction with Grignard reagents. Now here what happens is that the hydrogen of the alcohol reacts with the alkyl group of the Grignard reagent, resulting in the formation of an alkane plus a byproduct. Okay. Now is the reaction of alcohols with carboxylic acids. Alcohols generally react with carboxylic acids, resulting in the formation of ester, but that should be done in presence of concentrated H2SO4, which acts as a catalyst. This is a reversible reaction. Here, generally, water is removed as soon as it is produced in order to shift the reaction towards the forward direction. Removing water is generally done by concentrated H2SO4, which acts as a dehydrating agent also. Next is the reaction of alcohols with acid fluoride and acid anhydrides. In presence of base like pyridine. This also results in the formation of ester. Okay, I'll show the mechanism properly. Here what happens is that the lone pair on oxygen of OH will do nucleophilic attack on the carbonyl carbon. As a result, the double bond will be opened. regeneration of the double bond resulting in the cleavage of the CCl bond. Here also plus will be removed. This is what actually happens here. Okay, now I'll come to the reaction with acetic anhydride. There also ester will be formed as a product. Here also the lone pair will do nucleophilic attack on the carbon. Double bond will be regenerated and OAC will be cleaved. Here there will be formation of an ester. Along with that, a carboxylic acid will be obtained. This is the entire mechanism of reaction of alcohols with acid chlorides and acid anhydrides. Here acetic anhydride is used. Okay. Next I'll come to the reaction with halogen acids. With halogen acids, the reactivity of alcohol's order is such that 3 degree alcohol is most reactive than 2 degree than 1 degree alcohols. And halogen acid reactivity is such that HI is most reactive, then HBr, and least reactive is HCl. Since HCl is least reactive, therefore HCl reacts with 1 degree, HCl will react with 1 degree and 2 degree alcohol in presence of anhydrous Cl2 and heat should be provided. Okay, this is the reaction in case of HCl and primary alcohol. In case of tertiary alcohols or 3 degree alcohols, no need of catalysts. We can directly react hydrochloric acid in room temperature with 3 degree or tertiary alcohols. The reaction will be same as follows. But in that case no catalyst which is anhydrous ZnCl2 is not needed. Okay. Okay. Next reaction is the reaction with phosphorus halides. That is a very important reaction actually. Reaction with phosphorus halides is such that this reacts with PCl5 okay. This reacts with alcohol reacts with PCl5 resulting in haloalkanes, POCl3 and HCl as byproducts. Now this will also react with PCl3 as well. PBr3 also reacts with alcohols. PI3 also reacts with alcohols, but PBr3 and PI3 are generally prepared in situ in the course of reaction by using red phosphorus and Br2 or I2 respectively. Now I'll come to the reaction of alcohol with thionyl chloride. Thionyl chloride reacts with alcohols in presence of pyridine to give haloalkanes and SO2 and HCl as byproduct. In this reaction, haloalkane can be easily isolated as both the byproducts that are SO2 and HCl both are gases, and hence this haloalkane can be easily isolated from this reaction. Next I'll come to the dehydration of alcohols in presence of concentrated H2SO4. Now dehydration occurs at two different temperatures. When dehydration occurs at 170 degrees Celsius, this is obtained as a product, and when excess of alcohol reacts with concentrated H2SO4 at 140 degrees Celsius, then also dehydration occurs. But we get an ether as a product. Now I'll come to the mechanisms of these two hydration processes. Okay. First is dehydration at 170 degrees Celsius. This is the alcohol, and this is the structure of sulfuric acid. The lone pair of the oxygen atom of alcohol will abstract a proton. Resulting in this in the formation of this. In the next step, from this H2O molecule is separated, which results in the formation of a carbocation, which results in the... Okay, now let me write the hydrogen of this like this, and this one let me write like this. Okay. Now if this alkene is formed, then this is the most substituted alkene and this will be the major product, or we can call this as Sedgwick product. This is more substituted alkene. Alkene is formed at the most substituted carbon and hence this is the major product, or we can name this as Sedgwick product. And here if this occurs, then this will be the product, and this is the minor product because double bond is formed at the less substituted carbon. This is the minor product, or we can name this as Hofmann product, and this is as Sedgwick product. This is an important mechanism actually. Okay. After this, I'll come to the mechanism showing the formation of ether. Here also, the lone pair on oxygen will obstruct the proton. You have to keep in mind that all the alcohols are not protonated at the same time. As a result, the other alcohol is present in the medium. The lone pair will do nucleophilic attack and H2O will be cleaved. Resulting in the formation of this, then this will be obstructed and finally we will get the ether is water. This is how ether is obtained by dehydrogenation of alcohol. Next I will come to the reaction with ammonia. Alcohols react with ammonia in presence of Al2O3. Resulting in the formation of amines. Resulting in the formation of amines. water as byproduct. Amines. Oh, sorry for this mistake. I've mistaken something. If two methanol molecules are taken and under same set of conditions, we'll get a 2-degree amine. And if 3 methanols are taken, then we'll get a 3-degree amine. Okay, this is the reaction with ammonia. Now I will come to the oxidation reactions. In oxidation reactions, generally primary alcohols are oxidized by acidified K2Cr2O7 or acidified potassium permanganate or just we can write as then the alcohol will get oxidized to the aldehyde, which will be further oxidized to acid. Okay. Now if secondary alcohols are oxidized by acidified KMnO4, then we will get acetone. Secondary alcohol, we will get acetone. Acetone cannot be easily oxidized. It requires strong oxidizing agent, which is acidified potassium permanganate. Along with acidified potassium permanganate, it will require vigorous conditions. This will require vigorous conditions. Then only we will get a mixture of acids. Then only we will get a mixture of carboxylic acids. Now in case of tertiary alcohols, which are very difficult to be oxidized, acid oxidizing agents such as concentrated nitric acid is used. In case of tertiary butyl alcohol also, we will get acetone, and from there again with the use of concentrated nitric acid, we will get a mixture of acids. Okay, the last and the final reaction is reaction with halogens. Halogens act as oxidizing agents first and then as halogenating agents. Halogens react with primary and secondary alcohols resulting in the formation of aldehyde. This is the oxidation step where this chlorine acts as oxidizing agents and as alcohol gets oxidized to aldehyde. Next, in presence of excess chlorine, alpha position, and 3CCl3 will be obtained instead of CH3 of the aldehyde. This is the product which is obtained. In case of secondary alcohol, also same type of reaction occurs, but in case of secondary alcohol, here we will get acetone instead of alcohol. Okay, these are the chemical properties or the chemical reactions of alcohols. Next, in my next video, I'll talk about the phenols, and then I'll compare the alcohol properties of alcohols and phenols, and I'll give some tests, distinctive tests to identify different alcohols and phenols. Thank you.